is from thermal chemistry, and it's from like chapter 5, which was several chapters ago. But the thing is, we're going to do something with equilibrium constants, which, I mean, we talked about endothermic and exothermic and how that we treat it like heat is a product or reactant. But these enthalpy values, that's just telling us how much heat is absorbed or released. But when we're looking at equilibrium constants, we're looking at this, which really doesn't have anything to do with this. You do something similar, but it's different. And so it's a similar process, and I wanted to bring back this to your attention and kind of explain it instead of just saying, oh, when we do equilibrium, we square it instead of multiplying, but I wanted to explain why, okay? So anyway, it seems like I had to half these and reverse them. Did that happen? Yeah. Okay, so when you half those and reverse them, your enthalpy values were then exothermic and half as much. So my delta H for this little guy right here, they were negative something. I mean, well, I believe you, and you can tell me the answer in a second. And then this one down here, this bottom one, I think I let it go forward, and it was half as well. So this stayed negative, and so, you know, negative 36.2. I can do that. Yeah. And so negative 36.2. I guess you can tell me these other two. So 218.2, right?
Yep.
Okay. And so that is 196.25.
Just 96.
Just 96.
Just 96.25.
So I was right.
Yeah, you're right.
Okay. No.
No, it's 96.
Oh, just 96. Oh. Okay. All right. I'll give myself partial credit, or no credit, because that's completely not the same number. Thanks, you guys. Y'all are awesome. All right, so then when we want to find the enthalpy of this reaction, that's a combination of these. Remember when we talked about Hess's law and enthalpy of reaction? It's a state function, so you can look at, it doesn't matter how you get there. If you go straight to this or you do all this in series, you're going to get the same enthalpy for the reaction. So you don't really need to know the definition of a state function, but I think it's good to know. So anyway, when you add those, you add these, and when you add these, you get like negative 300 and something. What did you get?
Negative 350.65.
Did you say like 350?
Yeah,
Good. You get it?
Yeah.
Okay, does that ring the bell? Now let's just talk for a second. These are just heat that comes in, heat that goes out. Would there be any need for us to multiply these or square them or anything? Just get a little heat from there, a little heat from there. You put them together, get a little bit more heat. Now, here's the thing. Let's think back to our equilibrium expression. Do you remember this guy? This is our products, and these numbers here are the coefficients. If I go into a reaction...
Fourth block teachers, if I could have your attention, please. Please disregard the last email I sent you and the last text I sent you. We have a total change of plan that's going to make it easier for you. When we get ready to dismiss for the dodgeball game, I will ask you to just let the students show you their
right there at the, I'm going to explain this now point. Anyway, so if I, for example, let's just say to make it easier, let's just say that I took this reaction right here and I doubled it. I mean, I know I didn't double it, but let's just say I did. Okay? If I wrote the equilibrium expression for that, these numbers, they're exponents. So I can't just multiply k by 2. K gets squared. See what I'm saying? Now, let's think about it like this. On those top ones where I reversed it, if I reverse this and I write the equilibrium expression, this was the top of the fraction, but now it's the bottom of the fraction. So when you take and you reverse an equation and you're doing the equilibrium constant for it, you have to take the reciprocal of it. So if my k, like if my k for this one was, 2.1, and we reverse it like we did, we would actually be 1 over 2.1. And, we didn't just reverse it, we multiplied it by half, didn't we? So my k is 1 over 2.1, and the 2.1 is raised to the half power. That doesn't look very clear. Let me make it bigger. You have to do the reciprocal before you do the power. There's 3 questions on your test for this. Okay.
Where are we using this at?
I haven't even done I have a title point for this.
Oh.
So I wanted to help you remember what we had already done. I have like slides and you have practice. You're fine. But I wanted to just show you what we had already done because it's similar. Like it's I add that stuff up and then I do something. But it's not the same and I just wanted to introduce it. So I do have like some slides. So get out your slides and if you know. Thank y'all for actually wanting to learn today. That's nice. We'll appreciate this when we're doing acid-base equilibrium next unit. That makes me scared. So bad. So bad. Alright, so this is the last couple slides for you. I mean, it's almost at the end of your PowerPoint. So for K, EQ, and Q, they have the same formula. I'm at the end of equilibrium 2. This is basically, yesterday I was like, this is a whole new thing. I'll show you tomorrow real quick. And it's really not going to take very long. So you have the reciprocal rule, and that's what I was telling you. If you reverse it, you have to take the reciprocal. So let me show you that. I love when they use letters. So let's see about this. Okay, so this is my original reaction. So it's my magic pen that makes people not here see things. This is, don't freak out, it's a bunch of letters, whatever. But this is what we've been doing. If 2 is in front of this A, well, this is a reactant, so it goes on the bottom, and I raise it to the 2nd power. And then B is here, and D is raised to the 6th power. This is your equilibrium constant, and this is for this first reaction, for example number 1. Well, if I reverse the reaction, like I was telling you, well, my reactants are now products, and my products are reactants. So notice that this little guy used to be on top, but now he's on the bottom. Okay, so my new K value is now the reciprocal of the old one when you reverse it. You just, and like I said, if this was 4, if K up here was 4, all that, I did the math, I got 4, well, my new K value would be 1/4. And so you could redo this expression and plug in all the numbers, or you could just know that when it's reversed, it's 1/4. On your test on your test on Friday, because you don't get a calculator on the multiple choice, it'll say K is equal to Y, and then it'll have all the stuff reversed. K is equal to 1/Y now. Yes.
What kind of question is that?
It's a multiple choice question.
I mean, what is the K value now that the reaction's reversed?
Yes.
Okay.
Yes. And there's, of course, a little more to it. Just a little more to it. I know, it's I hate this. Stop it. Now, do you know a second ago when we had all those equations and we had to add them up and get the new enthalpy? We got done and then we added them all up and we got -350. Well, if you're having to do that same thing, if this is my new target, reaction, and I had to add these guys up, well, this crazy lettering here just says that I take the K value for this first one and the K value for the second one, and you just multiply them instead of adding them. Okay, so in summary, when you're dealing with this stuff, if you reverse the reaction, you take the reciprocal. If you're adding them together, instead of adding them, you multiply them. And if you multiply the coefficients by something, then your K gets raised to that power. So it's kind of like the other way, except everything is taken to the next level. Okay, so you actually have a couple of these practice problems, and those were the ones that I told you guys not to do yesterday. That happened, remember that? So there you go. Go ahead and knock that out. In this PowerPoint, it didn't have one of those 3 things that I just said. It wasn't on here. The multiplying. Oh, it doesn't. This PowerPoint, for whatever reason, it doesn't have the multiplying thing on here. I mean, I can dig out another example and show you that, but I think that's pretty straightforward to me. I'll turn this back on when we like go over the release exam questions.